Hello everyone, I am Vaishnavi, currently an intern at Emertxe Information Technology. I am doing this internship based on embedded system, and during this internship we have built a project based on MPLab XIDE simulating on software PicSimLab. We worked on the project microwave oven simulation. This project is built in a group of two members, I, Vaishnavi, and Rahul Kumar. The topics that we have learned during the internship: introduction to C language, array, pointer, string, function, and loops, introduction to embedded system, microcontrollers, MPLab XIDE for writing the code, XC8 compiler to compile the code. For simulation purpose, I am using PicSimLab, an introduction to various peripherals of PIC16F877A. The requirements for the project microwave oven are MPLab XIDE, XC8 compiler, PicSimLab, and PIC16F877A. So coming to what is an embedded system. So embedded system is the combination of software and hardware for specific function. Some characteristics of embedded system are: it is dedicated functionality, application and domain specific, reactive and real time, small size, and some examples of embedded system are microwave oven, washing machine, digital cameras, etc. So in this slide, we'll see the current sourcing and current sinking circuit. The first one is current sourcing circuit. When a load is connected to a device so that the device supplies current to the load, then the configuration is said to be current sourcing. An example is a series resistor and LED connected between a microcontroller pin and ground. When the microcontroller pin is switched high, then the microcontroller will source current to the load. In this configuration, a logic 1 will supply power to the load and logic 0 will switch power to the load off. This one is the current sinking circuit. When a load is connected to a device so that the current flows from the power supply through the load and into the device, then the configuration is said to be current sinking. An example of current sinking is when a series resistor and LED is connected between power and microcontroller pin. When the microcontroller pin is switched high, then the current to the load is switched off. When the microcontroller switches to pin low, current flows through the load. This slide is about the pull-up and pull-down resistor. First one is the pull-up resistor. Pull-up resistors are resistors which are used to ensure that a wire is pulled to a high logical level in the absence of an input signal. While pull-down resistors work in the same manner as pull-up resistors, except that they pull the pin to a logical low value. This is the matrix keypad. This is a keypad in which the number of tactile switches are connected in a row and column concept. This is used when more number of inputs are required. These are most commonly used in calculators, digital lockers, etc. Here, the rows are configured as outputs by giving logic 0 and the columns are configured as inputs by giving logic 1. This is the CLCD, character liquid crystal display. In PicSimLab there are two types of display, 16 cross 2 display and 16 cross 4 display. It is used to display the ASCII characters. Here the communication modes are 8-bit mode and 4-bit mode. As we need more number of rows in our project, so here we are using 16 cross 4 display and 4-bit mode because our tactile switch is also connected with same port, which is port D, in which matrix keypad is connected. Interrupt. An interrupt is a communication process set up in a microprocessor or microcontroller in which an external or internal device requests the MPU to stop the processing. The MPU acknowledges the request, attends the request, goes back to processing where it was interrupted. An interrupt service routine is a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it, executes the handling, and then returns to a logical interrupt value. Timers. The timers is nothing but a simple binary counter that can be configured to count clock pulses. These are used to measure the time or generate an accurate time delay. In PicSimLab, for the board PIC16F877A, we have three timers, timer 0, timer 1 and timer 2. For our project microwave oven, we are using timer 2. Microwave oven. So microwave oven is a kitchen appliance that uses electromagnetic radiation in the microwave frequency range to heat and cook food. The modes of microwave oven which we are using here are microwave mode, grill mode and convection mode. Also, we are using start mode to start the microwave oven. This is the architecture of PicSimLab. PIC16F877A architecture. This is the PIC16F877A architecture. Here we have GPIO, that is general purpose input output for connecting external components. Then I2C, then LM35 temperature sensor, then analog to digital converter. We have LEDs, buzzer and digital keypad, also matrix keypad, CLCD. All these are connected to PIC16778 processor. This is the PIC1677A microcontroller board. Here these are matrix keypad. Here these are 16 LEDs. These are ports. This is the PIC16F877A IC. This is the fan, buzzer and the CLCD display. Thank you. Now I will hand over it to my teammate Rahul Kumar and he will explain the project simulation.
Hi friends, myself Rahul Kumar. Now I am going to explain how my microwave oven will work. First I close it and I open the PicSimLab simulator. It is looking like that. First I show you the code of this process. So I am opening that MPLab X IDE. Here I wrote all code. This is the matrix header file and this is the CLCD header file, and timer main file it is, and this is my main.h and main.c file. Here main.c file I wrote all condition and all loops, and I include all libraries in this main.c. Here I include only main.h, and inside that main.h I I include um, all header file. Now I am going to show the output on PicSimLab simulator. This is my PicSim lab simulator. You can see here is many boards where I choose a pick generic board. Inside pick generic board I am selecting pick 16F877A board. This is my PicSimLab simulator, and this is my pick 16F877A microcontroller, and here it is the IC. Now I am going to start it by resetting my microcontroller. Again I am starting. When I reset it, it start from beginning. See first it welcoming power on microwave oven. Now here is the four mode: micro mode, grill mode, convection mode, and start mode. Inside micro mode, we set our microcontroller like that. It will take the time, and it will cook the food. So I am pressing 1 here for selecting microwave oven. So here it is showing it is taking 900 watt. Mm, Now I am giving the input as time. First I am giving 32 second and 12 minutes, and after entering you can see our fan is started, and you can also observe that a relay is on. Means whatever devices connected with this relay, it will become on, and our timer is also reducing second by second by the help of timer. Here there is three option: start, pause, and stop. If I press pause, you can see it uh, it stop at that condition only, and if I will start it, it will again start at that point only. And during start time, during running time, if I press key number 4, you can see it increase by 30 second. If I want more time to cook our food, we can increase by pressing this. Now this is the 6 number key. When I press 6 number key, it will comes out and show the menu. Micro mode and grill mode are same. In grill mode, directly we configure the time. So now I am showing the grill mode. When I pressing 2, it select the grill mode, and it shows the timer. Now I am set the small time 25 second only, and if I press the star button, you can see it will clear. And now I am giving 25 second only to show the output. Now when I press the hash key, it will start, and you can see mm, our relay become on, and our fan is showing a circuit is on, and it is a decreasing time. Only 10 second is remain. grill mode and micro mode is same. When it completed, you can hear the sound of buzzer also, and show the time up. Now I am going toward our third condition, convection mode. Inside that convection mode, first we have to give the temperature, at what temperature I want to cook. So I will give 125 degrees Celsius. Now I press the hash for enter. You can see it is starting preheating. After preheating, it will go to the timer set mode, and we set the time, how much time I want to cook, and it will start. Preheating time become over, and it comes to time set mode. Here I also give small uh, time, only 40 seconds, and I start. You can see fan start running, and like that our relay will on, and the heat circuit, means heater circuit will turn on by this relay. After time up, it give a buzzer sound. And at last, the fourth option is uh, start mode. If I want to heat something, or want to uh, light hot something, then I select that start mode. So when I press 4 key, it directly set to 30-second mode, and start directly timer. And if I want more time, then again I press 4 in running time only, it increase by 30 seconds. You can see. We can pause also, and again we can start. And if I want our food is completely cooked, so we can stop it directly by pressing 6 number pin. So I think you understand that working of this microwave oven controller simulation. So I thank to Emertxe to give that info, that knowledge to us. This thing is made by me and Vaishnavi. So thank you again to Emertxe to give me that opportunity to learn on this microcontroller. Thank you.